Good morning and welcome to the webinar. My name is Daniel and I'm the head of product design and manufacturing at Baker Baines. And welcome to the introduction to Inventor HSM. In this webinar, we're going to be discussing just an introduction to Inventor HSM and just looking at what you have available to you in the product design and manufacturing collection. The webinar is proudly hosted by Baker Baines, which is a gold partner with Autodesk in Johannesburg and in South Africa, actually. So let's get started. Just a quick introduction, the agenda itself. So we'll look at the CAM basics. So we'll look at some basic operations at CAM. And then from there, we'll look at some of the Autodesk HSM, what that's got to offer. You'll see some really cool stuff being done with HSM. Also, we'll dive into a bit of the technicalities on that. We'll look at some of the post-processor bits and how you can get access to post-processors for your processing of data for CAM. And we'll look at some of the information that comes with that, and also some technical presentations. So some of the, just a bit of a technicality, just to give you a bit of better insight into what it is. We've got a takeaway bit, and we've got questions to follow. All right. So let's look at some of the basics, so the CAM basics, so the CAM basic terms itself. So the basics terms that's related to CAM, we find that CAD, which is of course known as computer-aided design, CAM will be computer-aided manufacturing. So there's a slight difference in that. CNC, computer numeric control. So what this does is uses computer to convert the design product by CAD and CAM into coordinates, which is controlled by, of course, the machine and the cutter, which is part of the subtractive manufacturing. So subtractive manufacturing is removal of material, and that material being removed is not related to the parts that needs to be used or manufactured. PP, which is post-processor. This is a unique driver of specific CNC machine, and it's a link, of course, between the CAM software and the G code that it generates for a specific machine. And what this would do is it will allow the machine, it will actually control the machine, right, in instances of certain operations that's being done or managed. And then HSM, which is high-speed machining. Okay, this is more or less the type of the strategy of machining. You know, the software as well that's called HSM that you'll be using. And as you can see there, it's high spindle speed and feed rate, but smaller chip thicknesses lead to higher metal removal rate, increased efficiency, and of course, keeping up accuracy and quality of the workpiece. Okay, and of course, using this type of machining strategy, you know that you can decrease cost and machine time. Now, let's have a look and see more or less what this looks like. On the screen, you'll find that you can see on the left-hand side, that's a CNC milling operation, and on the right-hand side, that's the CNC turning operation. Now, this is removing material from a stock, solid stock block, and you can see how it actually machines it. So basically, what will happen is you do the design, you do the CNC or the camming bit of it with the operation itself. Once you're done, you post that to the machine using the post processor or the G codes, and the machine receives that, and you set up the tools and the workpiece, and you're able to actually do the machining itself. This is part of the subtractive machining operation, so removal of material. Okay, so the cutting process of the CNC milling side of it, as you can see, it involves the rotation of a cutting tool, okay, to progressively remove material. And very similar on the right-hand side with the turning, but just the orientation and the type of machining is different. This involves applying a fixed tool to a rotating stock, and of course, progressively removing material in that way. So that's part of some of the tools in Subtractive. We still have a few more that customers and people use. And the next one is the type of Subtractive as well. And here you find water jet, and you find with water jet the accuracy is quite high, and sometimes the thickness is quite high as well. Okay, plasma cutting, you've got accuracy of medium accuracy, as you can see there, but also you cannot go too thick, so the thickness cannot be very thick as well of the material that you're cutting. Laser cutting, the accuracy is high, quite high, but the thickness is low. So you got to maintain a specific thickness on that. And if we look at this in a bit more detail, you find that, again, as you can see, with water jet, uses high velocity steam or ultra high pressure water to cut the material, as you can see in the video there. But also with the plasma cutting, you find that it also uses a high velocity steam of ionized gas called plasma to cut the workpiece. And with laser cutting, you see that we've used it uses a high power laser to cut or engrave on a part. Okay. Let's see some of the basics of the subtractive strategies again. And if we look at some of the strategies that's adopted or available to you, we find that there's 2D, 2.5D, and 3D. Okay, machining. You've got fourth axis tool orientation that you could work with, fourth axis simulation simultaneously, which moves in both directions, as well as the fifth axis tool orientation. You've also got 3+2, and there's also fifth axis simultaneously. So let's have a look at this. As you can see, pretty straightforward. This is coming straight off the HSM software, and you can see that the machining profile being machined out there in the simulation. Next, you'll find that the 2.5D, you can see it's coming in, it's doing some machining. It's moving up X, Y, and a bit of on Z, but not actually full. And 3D, you'll find that curved edges, fillets are achieved by using the 3D strategy, as you can see in the model orientation in there. If you look at the fourth axis tool orientation itself, we find that the fourth axis, so the workpiece moves up in the orientation of the axis that it needs to move, and the tool comes in, does its machining, and it moves in its 3 axis, as you can see in there. Fourth axis simultaneously, you see that the workpiece and the tool will actually move simultaneously in the fourth axis simultaneous. And with the fifth axis, so 3+2, you'll find that the machining comes in, and the tool will come in to do the machining of the workpiece. Workpiece turns very similar to like the fourth axis, but it moves in different axis directions, adding the fifth axis to it. And we've also got the fifth axis simultaneously, so this will work very similar to the fourth axis, however, adding the extra axis for the machining operation, as you see in there. This is really cool. It's a very nice way to explain it. If you look at it, you can see what can be achieved, all right, using HSM. Now, if we move on, how can this be achieved? So if we look at the technology that's available for doing subtractive machining, you'll see that there's a list of technology people use on a daily basis, predominantly the CNC machines, that's the most common. We've got some laser, we've got some plasma, and of course there's some water jet as well that you could use to actually do your subtractive manufacturing. And where is this available to you? You'll find that in the product design and manufacturing collection itself, you've got a whole list of tools available to you to actually achieve your design. So first, the workflow would be from your design to your manufacture side of it. And the two key tools that's used for manufacturing itself, or subtractive manufacturing, or CNC, will be HSM, that's available to you in the collection, and also Fusion. Let's have a look at HSM itself and some of the applications or some of the areas that it's being used. So Autodesk Inventor for CAM for Inventor, that's the Autodesk HSM plugin that installs from the collection itself. If you're using a different CAD package, so it could be a SolidWorks package itself, you find that there's CAM for SolidWorks, so it also integrates into SolidWorks itself. And there's also Fusion 360, which has CAM for Fusion 360. So the CAM side of it is quite comprehensive. If we look at Autodesk HSM, you move on to HSM Works for SolidWorks, and for Fusion 360, that's available directly in the product design and manufacturing collection. Let's look at what's available in the HSM and the functionality itself. So you have access to HSM Express, which is free, and this just gives you 2.5 axis machining. So it's an Inventor add-in. It's also available for the SolidWorks, so the SolidWorks add-in is also available. So if you're using a different CAD package, you also have access to the type of machining available. And then we've also got the HSM, the Ultimate, that's embedded in the PDM collection, so the Product Design and Manufacturing collection. There's 2 to 5 axis available to you, and you've also got 3+2 axis, multi-axis, as well as turning. With Fusion Standard itself, you've got 3 axis available to you, and the Inventor add-in supports 5 axis as well as the SolidWorks add-in, which is really great. It gives you quite a comprehensive tool to actually do your machining. So if you look at the complete workflow, it looks at it from design all the way to manufacturing. So let's look at some of the functionality available in HSM itself. Again, you've got 2D, you've got 3D, okay, you've got the 3+2 axis machining, and you've also got multi-axis. You've got turning, you've got mill turn, which allows you to do a combination of both milling and turning. You've got probing, so probing is really, really important. A lot of people want to know exactly the measurements of their jobs, so they would generally use a probe. So you've got access to probing in here, and you've also got collision avoidance, which is really cool. So you actually avoid any fixtures that you're working with. Now let's have a look at the again the 2D or 2.5 axis. That's very important. We can actually discuss a bit on that as an introduction to HSM. So this is the 3 features that's available to you. You've got 2D adaptive clearing, you've got facing, you've got pocketing operations, you've got the profile operation that you could do. There's slotting available, there's tracing available to you. There's also engraving, which is really, really nice. Chamfering, drilling, and of course, core and circular thread. So you could also do some core machining as well. If we look at some of the traditional strategies used, so the traditional roughing strategy versus the adaptive clearance, you'll see in here that with the traditional roughing strategy, using the roughing strategy itself, the tooltip that's being used, it's basically on the tooltip itself, and it highlights it quite nicely in here, as you can see in areas of the tool where is it running in, and how does it behave. And it's only making use of just that little bit of that tool itself. If we look at the adaptive clearing, so this is more efficient roughing strategy, okay, with constant chip loads. So as you move along, you chip away and it works in. With the traditional roughing, there's variable chip loads that happens to the tool. So preserving the tool a bit, also making use of the wear areas of the tool, which is important, okay? And you can see, you can choose a type of strategy to actually use on the machining side of it. The advantages of adaptive clearing, you can see there, it's high volume metal removal using constant tool engagement. So you're going to use a lot more of the tool constantly, and removing material will be a lot quicker. So you're shortening the lead times. There's no load changes on it, okay? And also it preserves the tool life, so extending the tool life versus the traditional roughing method, which you can see on screen at the moment. I thought it's a really nice way to show off this, just to give you a better understanding of what the differences are between the two. So if we look at adaptive clearing itself, in here you'll find that in this video there's a really nice way to explain it.
Regardless of what the offset distance is, the tool will still see an increased engagement going into internal corners and driving into slots. These internal corners is where the tool is most prone to breakage. As we listen to the cut, we can hear that change in load coming into the corners and driving into slots. And monitoring the data coming in from our sensory tool holder, we see the spikes in load. So to maintain high feed rates, traditional programmers would take a light depth of cut. Unfortunately, this technique overuses the bottom of the cutter. In contrast, adaptive clearing maintains a constant radial load on the cutter throughout the entire cut. And we don't see those drastic spikes in load. Instead, we see a nice constant load. As a result, we can take a deep cut that uses the full fluid of our cutter with a light step over. This actually extends cutter life while reducing runtime. As machinists, when we listen, we can hear the constant sound of a good cut.
So that's a nice way to actually show off in a real life example of what's happening and how the machining of the adaptive clearing strategy works and how it actually removes material. As you can see, it's a really nice strategy. It gives you some advantages over just the roughing strategy itself. So let's look at the 3-axis functionality. So with 3-axis functionality, you've got access to adaptive clearing, horizontal parallel, you've got contour and ramping, okay, on the Z level finish, as you can see in there. You've got spiral and morph spiral, you've got radial, projection, morphing, scallop, pencil tracing, and you've also got the 3+2 machining on it, okay. If we look at some of the full 5-axis functionality itself, we've got swath cutting, multi-axis contour. So for your complex contours, automatic tilting. Okay, so to use with short tools. So of course, using larger tools, you might promote a crash. So that's a little tip on that. And you've also got the 4th axis tool wrap, which is very nice. If you kind of do a spiral along the cylinder, you'd actually use that strategy to achieve that. Now, let's look at some of the functionality on the turning side of it. With regards to HSM turning, you see that we've got the facing and the profile operation that can happen. Right? There's the grooving operation that could happen. So for grooving, parting off or cut off operation that's there. There's also threading that can happen there. There's drilling, boring, chamfering, and also stock transfer. Right? So between 2 chunks in there. If we look at some of the turning operations, again, as you can see in the image itself, you can see this profiling, grooving, single grooving, some facing. You can do parting as mentioned, chamfering, and also the stock transfer, including the mill turn, which is really great, which allows you to do actually both. Okay. Some of the added functionality you can expect to see with HSM is, of course, the stock model rest machining options in there. So rest machining, we could dive into a bit of rest machining on the next webinar around HSM because it's a very nice topic and there's very nice information to share on that. You've also got slope-based machining. You've got the CNC editor, so you can actually edit up that G code or the post that's been processed. So the code that's been processed that can be edited. You've got probing. So again, going back to probing functionality is available in there. You've also got automatic setup sheets that you could use, or that could be set up, and then you could just include them to be used in different operations. But also stock simulation and verification. So again, also with the stock simulation, you actually input the amount of stock being used in the environment. If we go into looking at what the post processor gives you, this is what it looks like. You've got something like a little notepad format, very similar to Notepad. You can open up Notepad, and it tells you the operation and also the code. So it's the encode that you can see on here, with, of course, as mentioned earlier on, with information on where it sits, where the tool sits on the workpiece, and how it's moving in, moving forward. Where's your starting off point and where's your end point? So we can look at that in another webinar where we look at what the G code's doing and what the post processor is giving us. To access the post processors, of course, to actually post to your machine, you need to have the post processor set up, which is very, very important. And without the setup, it's actually basically not going to work. You got to have the setup. Autodesk, fortunately, provides quite a bit of information with regards to post for a lot of the controllers that's available to us. And I think there's quite a bit of post available online itself. It can be downloaded from the link below. So it's cam.autodesk.com/post/, and you can go in there and search the post library to actually pull out the post for the correct controller that you're working with in the machine. And also there's the CNC handbook that's available to you, which actually gives you a lot more detail into the post itself, which is really great. So for anyone starting up with HSM or want to actually use HSM for the CAM environment, I'd recommend going in and having a look at the CNC handbook. It's really, really insightful, and there's a lot of good information in there. So let's get into some of the technicalities of it. So the technical presentation. So in here, we're going to just discuss a very simple operation, look at the setup itself, and you can see how you could actually achieve some machining, right? So the design and manufacturing of the fixture. So this is the fixture that's available to us. We're going to actually go into that and actually do a bit of machining. So starting here. So of course, at first, we jump into the CAM environment, and it's important for us to actually determine the orientation of the tool and how it's going to look. So the tool library. So we're going to go into the tool library first. And with HSM, you have access to creating your own library, removing libraries, or importing an already created library. We're going to create a new library quickly, and call it in there. If you go in, you can import a tool library from an existing library. So it's a .lib file, okay? And this tool is going to be done using for aluminium. So we open that up. The support file that comes in, and you can see the tool that's available, the sizes of the tool that's there, and the different types of tools. So we're going to jump into the setup. So important setup is very important. As you can see, the stock that is formed around the workpiece itself. We choose the operation that we're going to work with. Of course, in this operation, you've got multiple options: milling, mill turn, or turning, or cutting as well. And then we choose milling. We go into the WCS, which is the work coordinate system, and the indication of our Z-axis, which is important. So we can actually orientate that, as you can see in there. All right, you can flip your Z around. Depends on your setup itself. And you can also flip around the X-axis by just picking on the arrows. Now, what's really great about this is you've also got a stock box where you could have indication of stock as well. It's also the model point, so where does the base point or the start point of that tool going to come into? You can choose it from there, right? If you've got any fixtures, you could indicate fixture, and you could show off these fixtures at the bottom. But if you're just looking at what's happening here, you can see that's the model point that's showing up on the screen itself. Again, looking at fixture, if you click on that, you can indicate what is the fixture, what is the workpiece. So you're not machining into your fixture itself. So with the setup done, we can start doing some operations with this. We can start looking at perhaps doing a 2D milling operation in here. And in here, first operation is the facing operation. We're going to choose a tool. So it's a workflow. Choose your tool, choose the geometry, choose your heights, your linking, and your passes, and you can work from there. So in here, of course, the tool, we're not going to do a face tool. We have to actually pull up a face tool. And in our library that we just added, we see that there is a flat you could use. But of course, if you're facing, we're going to use the 6mm flat in here. You can set up your feeds and speeds, which is really great. So it's automatically inputted for you based on the tool. However, you could also manually add that in. Stock contours, it's automatically in the selection that's in there for you. Okay, so on the geometry tab, you could pick it. Okay, alternatively, what you could also do is set your heights as well. So in the heights tab, you could actually see how far it's coming, where is the tool coming in, from the model top, model bottom, top height, and of course feed height as well, which is really great. I mean, if you look at this, you can actually adjust and see where the tool is coming in, how it is actually coming in to the machine itself. We've also got passes. So with passes, you can actually choose the type of machining that's happening in here. So with the facing operation, there's not too many. You can choose the tolerance coming in, pass direction. Okay, so changing direction of the pass. The extensions, of course, how much does it extend past the workpiece itself, and you can also edit the step over extensions as well. So this is adding an expression in here. You could go and add the change expressions as well, and by changing expressions, you'll see that you can do some modifications to the operation itself. Linking, again, you can actually go in and look at the lead in, lead outs in here, you know, and the transitions. Once that's done, if you click on it on the operation, you can see it is successful. You can see how it's going to do the machining. It's coming in there, it's curving across, and it's going out. Now, that 5 mil that you saw there, that was actually the extension of it, and you can see it extending out. You can see the lead in and the lead out. So the lead in and lead out in this example was the same. If we run a quick simulation on that, you can see take off the stock or show the stock. It depends on how you want to view it. You could actually see the machining of the facing operation, how the tool moves. And you can see how that was done, which is really cool because it gives us an indication of that. So the next operation is looking at doing the holes that you see there. So we could go in and use a boring operation in here. Again, same workflow, select a tool, select the geometry, and then set up the operation with the linking, the passes, and of course the heights. So we're going to go in here, choose a geometry. We're using the same tool again, pick the geometry up, and you can see that we're not going to do the bottom piece, it's just the top part of it. And where do we start it? So in here we can choose the bottom height. So if we choose the bottom, the whole of the bottom, there's an offset as well. So is it going to offset 2 mils from the bottom? Alternatively, it should be 0, right? We can also modify that in our heights tab, and we can start looking at the tolerance of what we're doing. If there's any stock to leave, you can also indicate stock to leave as well in the operation. Next operation is a drilling operation. So in this operation, we can actually go choose the tool. So we'll use our drill. It's a 5 mil drill. Select that, and now we're going to pick the looking at the speeds and feeds that can be modified as mentioned. We can look at the holes that we're going to work with. Now automatically, because we've got the select same diameter, it's really cool. It allows us to select the same diameter. It picks up the same diameter of the diameter selected in the model, and it'll highlight that for machining. If we look at the heights, how does it come in? So we can choose the bottom height or whole bottom again, and we can pick the whole bottom, okay, to actually show where it should actually stop or where's the whole bottom. And we can say drill through bottom, and we can also put a depth to add in. So we know that it's going to drill past a specific depth, which is great. We could also do a model top, okay, to see, and just to show you what it does. If you look at top height and bottom height, it should of course start at the top of the model, and the bottom height will indicate the bottom of that model itself. Now looking at the operation itself, you can see the boring operation and you can see the drilling operation in that, which is really nice. So in this example, you've seen that we've done some simple operations. The first one was looking at a facing operation, just doing the facing of it, and then using the boring tool to bore out the 2 holes, and then using the drilling operation to actually drill out the next hole. If we carry on with that, you find that, sorry, swing back there. With the next operation, you find that in here, what we can do is we can actually look at going into doing the rest of the machining in here. So this, we're still using the 2D milling strategies in here. Previously, you could use adaptive clearing on the 3D milling strategies. And in here, firstly, select the tool that you're going to work off. Go into the formal flat, select that. And again, the geometry. Okay, so geometry is important in here. We've got to go in and choose either a selection or silhouette. So if you go into selection, it's important to actually view your selection have a good view of it. And if we pick that up, it picks up the full selection. We can look at the heights again. So in the heights tab, again, model height. So we're looking at top or bottom. So where does it end? So it's important we only machine that pocket out. So we got to choose that height there. Now notice that there's variance heights. So it becomes important when we're looking at it. The tolerance again, we can choose the tolerance that we're going to work off. So as we're machining, and also the optimal load. So optimal load, that's the load of the tool that's going to be we working off, and also maximum minimum cutting radius. Okay, directions. So we're going to use a climb, right, and also the maximum roughing step that we're going to be working on, right. So it's not going to be the finishing operation. It's more from the roughing because our first cut. Any stock to leave, we can input that. So we're going to go 0.1 stock that we could leave, and again the actual stock to leave, again that will be 0 in there. Okay. Now, if we look at the operation itself, we're using the 3D adaptive, so it's adaptive clearing. You've also got 2D adaptive that you could work with, but using a 3D tool, 3D strategy would actually be quite helpful. So it gives us a lot of information. So how do we want the tool to come in? Are we ramping? So I'm going to use the helix. And what's great about this is if you hover your cursor around the tool, you find that it gives you a little indication or explanation of what's going on. The strategy is busy calculating at the moment. And if we look at it, you can see how the tool's coming in. So it automatically picked up the heights of what's going on in there. So I'm going to do a quick simulation of this to show you. Machining of it. As you can see, it is a helix, the way it's actually cutting in. It's going to do some clearing out there, and automatically the heights are selected, which is great. Because if we use a 2D strategy, we could have used a 2D strategy in this, but we would need to select the 2 different heights, let's say. So it would be 2 different operations. So to save time and to have it machined a lot quicker, we just use the 3D adaptive clearing on it. It's really great. We come back to our contour 2D now, so we're going to jump back into 2D environment, the 2D machining strategy again. Pick our geometry selection, so we're going to pick that bottom. So in here we can come in and perhaps do a finishing cut, and selecting the face down there, selecting that bit there. So there's 2 different height selections that's coming in. Okay, that we've got to make sure that we select. We go into our heights tab. Now we've got to indicate the stock bottom, which contour we're working with. We can look at our passes. We can modify tolerance in here. We can do some edits to it. Okay, so as you can see, it's a lot. There's no stock to leave, so we're going to machine it to final cut or final size. We can modify our lead in, lead out, so we can change that. Is the lead in, lead out going to be the same or not? We look at the ramping as well, so the maximum ramp step down, that could be edited. If you look in here, you can see what the strategy and what it's actually doing. Now what it's going to do, it's going to do the final cut on the sides to actually finish that off. We can go back and edit it. Perhaps change feeds or speeds if we need, or lead in, lead out feed rate. As you can see there, the ramp feed rate as well can be modified. Also the cutting feed rate as well, which is really important because we have that access to actually go in and modify certain aspects of our machining strategy. Go back into it, we can see that the tool we're using is a formal flat, the geometry, the contour selections. We're going to go in and add that contour selection in now. Again, we could come in and modify the heights. So select the contour, so it's not the model top or bottom. It's select the contour that we've indicated. We could say stock to leave. Nope, we can actually go in and do a machining. So we can go multiple depths, which is great because we can see what's the maximum roughing step down that we're going to go in. So it's going to be multiple depths, and you'll see once we've okayed it, you can see what the geometry is going to look like. Lead in, lead out is going to be different from each other, or it should be the same actually in this example. And as you can see, it's busy doing the machining on it. Okay, if we go into ramping, we can actually go in and check that out. So maximum ramp step down will be 1 millimeter in here. We go in and you can see there's a lot more happening because of our step down. So we've added a smaller step down, so there will be a lot more step down coming in. If we take ramping off, we can actually see where it's going to come into. So that gives us an indication of our tool path. We can actually see how the tool's going to come in, what it's going to do, which corners it's going to go into, how it's going to actually machine it in there. And this, of course, can be modified to suit your environment and the way you work with it and the way you can actually do the machining operation itself. Now, if you look at the contour, you can see that it's not cutting out a curve for us. It's just squaring it out. But of course, the tool that we're using will manage that fillet for us. We can duplicate that. So by duplicating it and doing an edit, we don't have to go back and reset or redo the complete machining operation. The tool's already selected for us. We choose the outside, the bottom, to actually machine outside for us. So using these tips and these tricks that you see here, there's many ways to actually go about machining this. However, which would be the quickest or the fastest way to do it or the best strategy to use, that's of course decided by yourself when you're doing it. And the vertical lead in lead out radius, you could actually have a degree that you set on the sweep angle itself. That's okay. We could actually see the machining operation. So you see that sweep angle that's being created in there. So as it's coming in, the angle that the tool uses, so it goes down, and you can actually see how it's actually gonna come in from the lead out. So how does it curve in with that angle, and it leads out, but the lead in is actually coming in straight. So that's something to pay attention to when you're doing it. You can actually set that up inside of the setup when you're doing that. If we move along, we find that in here again. Sorry about that. Move along in here. It's a very similar operation. Just to recap on that operation that we've just covered. Looking at doing the chamfers that's inside here, that could also be done, and actually seeing how that operation is complete, which is great because you've obviously got the tools to actually do the chamfers on that's created from the model itself. So for picking edges, you could actually create those chamfers that you see on the model itself. Okay. Using the contour 2D, by looking at the heights again, structurally, this could be a finishing cut that we can do. But if we go into our tool and we select the chamfer tool, it's in there. Notice that previously when we looked at it, it didn't give us this option for chamfer in our passes. However, once we select the chamfer tool, we've automatically shows up as a chamfer that needs to happen. So you can see that the HSM is quite clever in a way that knows, depending on the tool that you're using, it's a chamfer operation. You could actually go in and do, you're actually doing a chamfer. So it knows that the chamfer needs to be indicated. We select our geometry again. We could actually go in and pick up the geometry that needs to be chamfered. So we'll pick up the base there. We can go in and look at the operation that we're working with again. There's other areas that needs to be chamfered. You can pick that up. Or you could alternatively use the 2D chamfer. All right. So it's not necessary that you have to use the contour 2D to do it. You could use the 2D chamfer, or alternatively use the contour 2D with the chamfer tool, and you'll have access to do a chamfer on it. We go back in here. We can choose the chamfer width, as well as a chamfer offset, tip offset. that we're going to chamfer. So if it's a two-mode chamfer, of course, you'll have to work that out and put it into the chamfer box. So if you hover your mouse, as discussed, you can see what that chamfer offset, tip offset is actually doing. So if you look at that operation, we can see that it's actually going to give us that chamfer in there. So if we simulate that to show points, if you click on that and actually move into it, you can see that it's giving you a perfect chamfer at that angle that's selected and where the tooltip is from the offset, which is great. Which is really, really nice, because when we're doing chamfers, it's nice to actually see, using the tooltip option, to actually see where the tooltip is going to be. Okay, so if we move along, we'll find that again in here, there's looking at the chamfer like what we looked at earlier on, you could see it in there. So looking at the takeaways from the session, you found that we've discussed adaptive roughing, so 2D, 3D, we looked at some 4-axis operations as well that could be done. Notice that it's quite easy to customize with regards to your machining operation that you're doing. So you could go and do some edits, do some changes to it. There's duplicate methods, so you duplicate the machining operation, do some changes to that. So it's not, it actually allows you to speed up the process, and you're not doing the same operations twice. It's quite fast to get G code once you post process that to the machine. We're going to actually cover that in the next session, where we look at actually posting. So once we've done the job, now we go in and post that. Post processes in the libraries for many different machines, as you've seen earlier on. You could actually download those posts directly from the Autodesk website. If you guys need the link for that, please feel free to pop me an email, and I'll be more than happy to share that link with you and the content that's in here. But what's great about this, you get HSM that's included in the takeaways. In the PDM collection as part of the takeaway. So you have access to the software. All you've got to do is adopt it, get onto it, start working with it, start using some of the tools, get used to it, and you'll find that within no time you'll be doing machining operations when using HSM. So I'm going to open up for questions now. If there's any questions, or anyone wants to add any questions to this, please feel free to use the chat box, and I'll be happy to answer that. Thank you. Alternatively, you could always send me an email. My email address is Daniel, DANEEL, at Baker, BAKER, Baynes, BAYNES.com. And I'll be more than happy to answer any questions you have regarding HSM itself, or the questions with regards to the presentation that you've just seen. Thank you very much for joining, and have a great day ahead. Thank you.